Hello everyone. In this video, I'd like to use this IOLink master with EtherCAT field bus function using my laptop as Beckhoff TwinCAT controller, and using this Win IOLink master with EtherCAT feature. And IOLink, I will use the FM05D150, this IOLink device, as my IOLink test system. In the previous videos, I demonstrate how can we use IOLink master with PerfectNet field bus, Ethernet IP field bus as the IOLink test system. This is my first time using IOLink master with this EtherCAT field bus. And in this test, this IOLink master, this type is IOLink M12-ECT-P-88. Okay, this IOLink master. And this is the power. This is EtherCAT bus and connect to my laptop. And my laptop will run as Beckhoff TwinCAT controller PLC. And I will show how can we read this process value and how can we write the parameter to this IOLink device. Okay, let's go to TwinCAT system. This is my TwinCAT engineering laptop, and I installed TwinCAT XAE shell. Okay, and to integrate this Win EtherCAT device into Beckhoff system, we need to copy this ESI file into Beckhoff TwinCAT, the EtherCAT folder. So we will copy this file into TwinCAT folder, which is under C drive TwinCAT 3.1 config IO EtherCAT, this folder. And we need to paste the ESI file into this folder. Okay, we'll paste it. And after this, we will open TwinCAT XAE. And in this video, I will use this laptop and I will directly download this program. So in your case, you might using Beckhoff controller. So you can use your remote Beckhoff PLC as your remote PLC. Okay, so we'll go to File and start create a new project. Okay, I will create one project named TwinCAT IOLink under this directory. Okay, and click OK. Definitely in this case, I will use my laptop Ethernet as EtherCAT function. So firstly, we need to guarantee your target controller. The Ethernet adapter has been installed with TwinCAT real-time driver, show runtime Ethernet compatible device. So make sure your Ethernet connection support EtherCAT function. Okay, in this case, I installed this driver already. Then the compatible Ethernet card, typically it came from Intel. Okay, so you install this first. And then once we create a new project, so from here, device, we can add a new EtherCAT master. Okay, and we are at configuration mode. And now let's double click. And let's firstly try to search, configure this EtherCAT master. So we need to tell this EtherCAT master which card we are using. So from here, I can click search. Okay, this is my connection, this Ethernet adapter. Okay, this card. Okay, we configure this one. Then from here, we can click scan. And now this system automatically scanned this device. So which is the same type I just showed. So here we can name this one to the brand. And from here, the EtherCAT device, it also automatically scanned this EtherCAT address 1001. From this process data, we can see this automatically scanned. And from the slot area, so default, this master config as the digital input. And once we click here, we can see, so for each port, we can config different brands of the IOLink master. It would have a different configuration style, but they are quite similar. In this case, my IOLink device is connecting to the port 0. So here, I will firstly click this delete. Okay, default, it is digital input. So I'm connecting FM05D150, this IOLink device. And according to this device, this is the FM05D150, okay, laser distance measurement sensor. This is vendor ID, device ID. And this sensor from the process value area. So this 05D will use 2 bytes, 16 bits. So back to here, we will use the input 2 bytes. Config. Okay. Once we configure this port, we will see here it automatically show up this device module 1. 2 bytes here. Okay, and we'll see 2 bytes configured here. So in this case here, we can rename this one to O5D. Okay, this IOLink device. Okay, then back to here, and then this is startup, so configuration. And this COE area, those are the configuration parameter here. So typically, for example, if we are going to write the parameter to the IOLink device, we will use this 8100 area. The port 0 is 8100. Port 1 will be the next. Okay? And this is the ISDU, the parameter writing area. If we expand here, we will see index number, subindex, length data, and control. This is the command. We can read or write the parameter to the IOLink device. I will demonstrate this shortly after. Okay? And then we can also go to 9000 area. And here we can see, since this IOLink master is connecting to this IOLink device, it automatically identifies this device. As we can see here, this device ID and the vendor ID. If I open this menu, and for this O5D IOLink device, its vendor ID is 310 decimal. Okay? And device ID is 372. So this 9000 area is a read information. Apparently, IOLink master has been identified this IOLink device. In any cases, if your IOLink master cannot automatically identify the device, you can also directly tell this master which device, the device ID and the vendor ID is communicating. Then you can go to IOLink setting port 0. So here you can also configure different IOLink master with EtherCAT function. Sometimes this parameter would have a slightly different, but basically you will find a similar area like this way to configure the device ID or vendor ID. Okay? So in this case, this IOLink master automatically identifies this device. We can read this parameter already. We will leave here. 16 bits, it read. Okay? We can also go to online and we can see currently we haven't downloaded those configuration yet. That's why this device currently haven't started working yet. It is at the initiate status. Okay? Now we haven't set up the PLC controller yet. Now let's go to set up PLC project. So from here, PLC, add a new item. And we will set up this PLC under this project. We'll call this PLC as IOL. Okay, okay, we create this PLC project. Okay, and then let's go to system. Firstly, let's go to license. Okay, we will activate the license. If your license shows expire, no problem. You can click 7 days trial license. Configure your PLC runtime. Let's go to real time here. And I can firstly read from target. If this is your first time configure this, then you can firstly read from the target, identify how many cores from your system. So in this case, my CPU has 4 cores, and I can select this isolated. So this is a dedicated core for this controller. This CPU will be assigned with this isolated core. Okay, after this, let's go to PLC task. So in this case, I assigned 10 milliseconds as this PLC scan time. Now we can compile. Okay, now the system shows device 1 needs synchronized master. That means we haven't linked any task variable yet. So in this case, we will go to variables and we will create the global variable list, GVL, and we will create 2 variables to link these 2 input bytes. Okay, we will declare 2 variables. Okay, one named the byte input 1, byte input 2. Okay, be careful of this format. Okay, and then we will compile, build the solution. After build solution, so this will be compiled. Then we are able to now right click, click this change link. We can link this PLC variable and link the second one, input 2. Okay, once we linked, then this PLC project is also connect with this EtherCAT field bus. And now let's build again. Okay, no error. we built successfully. And now let's download this project. Click this active configuration. Again, before we download, you need to make sure either you are using your local or you are using your remote PLC. Okay, the target PLC. Okay, now let's click this download hardware configuration. Let's download. We'll see this status here. All right, after the download, we will see this indicator become green. Before it was gray. So that means now this IOLink master with EtherCAT function, it has been communicated with this EtherCAT master, which is my laptop. Okay, and this one also means this master identified this device. IOLink device is measuring this 48. So we will see it's measuring 48. Okay, now 22, 21 now. Okay, going back to this configuration now. Firstly, let's identify this EtherCAT. Let's go here. Let's go COE online. We will see this identified this IOLink master, this information. And if we go online, we will see this address is 1001 and the status is OP. And if we go to here, EtherCAT, we can go to topology. And we will see the online status show topology. Okay, this status shows this controller now is communicating with this EtherCAT device. It's also the IOLink master. And then let's go to this EtherCAT device. It's also the IOLink master here. So its current status is OP. That means it's operating. Okay, status is correct. And then let's go to this COE online. Okay, and 9000 here, again, is reading this correct status now. And meanwhile, we can also go to the port status here. And we'll see the port IOLink status showing 4, which means it's correct. To compare this, the port 1 now is not connecting anything, so its status shows 0. So this status can also tell us the current status from this port. And now let's go to the process data. Go to this module 1 has 2 bytes input. The input byte 0 and input byte 1. Okay, we can go to the online. At this point, we haven't programmed anything yet. It's directly reading the raw data from this module. So currently it's 81 and the byte 0, it is 1. So what does it mean from these 2 bytes? Now, if we go back to the menu from O5D 150 IFM module, if we scroll down, go to the process data, IOLink device process data. So as we can see, these 2 bytes, it is this byte and this byte. Okay, and this byte, the lower 4 digit represent the switch status. And the orange area, it is actually the processed value. The processed value represent centimeter distance, which is same as the display. Now currently it's 21, 22. So if we go to this byte here, since the 4 digit represent the switch status, it's not exactly the same like a 21 value here. But apparently if we are moving this sensor, we will see the value is changing. This is raw data. Now, if we move this status, and now if we move this object, we can definitely see this chart is changing. Okay, means this TwinCAT controller now is reading this IOLink sensor. The next thing is we will convert this 2 bytes into a correct process value. Basic idea, if we go back to here, so we will read 2 bytes first, and then we will convert that 2 bytes, join them together as one word. And after that, we will shift 4 digit to get rid of this status. We'll also grab this switch status out. Then we will program one additional simple logic from the PLC area. So from here, we go to the POU here. I will create one very simple way. We will create one POU and we will name that O5D 150 underscore process value. And in this case, I will use the ladder logic and I will use a program style. Very simple way. In the real case, we better program this as a one function block. To briefly demonstrate this, I will use the program. This way is slightly easier for the new user. Okay. And here we will declare some variables. Okay. We will declare those variables and then we will program the ladder logic. So from here, we can insert box and we will do some program here. You can search the command or you can pick the functions you can use. Okay, from the standard here, SR, counters, or timers from here. Okay, I prepared this program already, so I will directly paste here. I pasted the program here. Idea is the byte 1, byte 2 will read in first. We'll convert them to a word, and then we will shift 4-digit SHR using the shift digit. And basically, this is the idea. And finally, we will convert this result into an integer. The integer can come from a global variable. And the switch status, which came from a threshold from the IOLink device. So that switch status, we can create another bool to convert this .0. .0 means this is the lowest digit here. Here, we will convert to a global variable. So that means from the global variable list, we will also create another variable at here. So the first variable is integer, receive the process value from this IOLink device. And second is a switch status. Once the sensor distance greater or lower than a threshold, then it will be turned on or turned off. Okay. And after this, from the master, we haven't called this program yet. And from here, we can just call O5D 150 underscore PV. Okay. We'll call this program. Okay. Call this one. And from here, let's log in. Okay. So now let's jump into here. We will see currently this byte 0 now is 1. The second byte 1 is my here. Input 2 is reading 113 here. And finally, this result convert to 23 centimeter. And currently this switch status now is 1. Okay. You will see this whole value here. Okay. And now if I move my target, okay, you will see now it's 17. It's 17 now. Okay. If I move up, I remember my threshold is 30. And now we will see this switch status now is off. Once I lower than 35, okay, 22, now the switch status shows on. We will see it's exactly same as the real status. Okay, means our current process value is reading correctly, and also we convert this process value into a correct status. Okay, this is the process data. Firstly, we read from these 2 bytes, and then we convert according to this menu from this IOLink device. If you are using other device, maybe the way will be slightly different. Or maybe you can just directly read this bytes and then convert to a word, then you can directly read the value for your IOLink device. Okay, this is the process data. It's quite straight. Next thing is ISDU, the parameter. If we need to change the parameter by using this IOLink master, especially through this EtherCAT field bus, how can we do this? So if we scroll down, next section is talking about the parameter from this IOLink device. For example, for this case, if I'm going to change the parameter for this display, the index number is 96, and sub-index is 0, and the length is 1 byte. How can we do this change? So now we can go to the IOLink master here, and from this COE online, and now we can find this port 0. The port 0, for changing the parameter, we will find this ISDU configuration area. And the port 0 is here. We can expand here. And now we can prepare this parameter at here. We will change the index number to 96, 1 byte. So here, we will change this index to 96. Okay, 96. And sub-index is 0. And length, it is how many bytes for this parameter, either integer or byte. Typically here it is 1 byte, so we will write 1. And to turn off this display, we will leave the value to 0. So we will leave this default is 0. And now, if we are going to change the parameter, and we will control this parameter for this control. So double click here. Default is null. It's doing nothing. But if we are going to change the parameter, now I can select this right. Its value is 2. Once I click OK, then this parameter and this value will set into this IOLink device, which will control this display here. We will see. So now, 1, 2, 3, click. We'll see this display turns off. We are able to change this device parameter. And to turn it on, so we will change this parameter here, this data. This data, to set 1, be careful, the 1 will be the very left. So for this digit, we will change to 1, means we will turn on this display. Turn on the display will be the 1, okay? So we will turn on, click OK. So we'll see this display turns on. And we left this right value to right. So that's why once I change the parameter, it's changing on the fly. So once you set the parameter correctly, don't forget you can turn this off. Turn this to null. Then the parameter we can left here is not going to control anything. Okay? This is going to show this idea for this ISDU IOLink device parameter changing. And some cases, if you like to permanent to change the parameter, for example, even though we are able to change this, but in case sometimes if your control system reboot and your parameter may be lost, then you can configure this parameter add to startup list. Just click this. And then from your startup list, you will see this 3 parameter. You can configure this 3 parameter and this into your startup list. Then once the system starts up, it will write this parameter to the IOLink device when the system starts up. This way, you do not have to program anything. You just every time your system start up, then this parameter will write into this device. Okay, this is the video of how can we use this IOLink master with EtherCAT field bus function. And this is the typical way as the IOLink master with this EtherCAT, then we can change this parameter and we can verify the status from the port from this 9000 area shows the real correct status from this IOLink master and IOLink device. So this case, I'm using this brand, but in case one day you are using other brands, the idea will be quite similar. Maybe the only difference is some cases, the parameter, this index number might slightly different, but the idea will be the similar. Okay, this is the topic for today. This IOLink master with EtherCAT feature. Thank you for watching. Thank you for watching. If you like this video, please give me a thumb up. If you like to watch more videos in my channel, please subscribe and hit the bell. Thank you for watching.